sunshine as a so-called light giant, did this delusional belief change somewhat, namely through the Danish astronomer Tycho Brahe, who provided evidence for the fact that tail stars were celestial bodies that drew their course far beyond the lunar orbit through the Solar System. With this, the form of the course still wasn't recognized for a long time, however, because a more precise determination was first achieved over 100 years later by a certain Gottfried Kitch. It was this man, then, who also observed the destroyer, whereby he discovered it with a telescope, which also happened for the first time in the history of the comet's discovery. That was in the year 1680. With this passage, the destroyer was visible for a very long time, namely from the 14th of November, 1680 until the 19th of March, 1681. It also drew a gigantic tail 80 in length behind itself, which is a typical feature that occurs when a comet passes very close to the solar surface. Ptaah explained the matter to me in such a way on the great journey. Kitch didn't discover the destroyer intentionally but only through a happy stroke of fate, as he observed the planet Mars. Now, the Solar System's comets, which are also known as cosmic beacons, are subject to the Solar System's mechanical laws, and they are integral members of our solar system. This is so, even though they often move very far out into the space beyond the most distant planet Pluto and into the two belts, from where they had originally come. Sooner or later, on their closed courses, they return again and again to the inner solar system, also often in dangerous proximity to the Earth, just often first after centuries, millennia, or after many millions of years. In the 19th century, when the Earth people invented astrophysical research methods, details became known and were also recognized for the first time in reference to the nature of comets. Thus, it became increasingly clear that tail stars are actually just relatively small bodies that, nevertheless, go through very dramatic changes once they come into the vicinity of the Sun, and through its rays, the formation of the comet's tails results even the actual feature or characteristic of the feather stars. Thus, comets are among the small objects of our solar system. In contrast to the planets, cometary structures usually move in very elongated, elliptical orbits with eccentricities. Thus, comets are, with few sporadic exceptions, celestial objects that always return at periodic intervals. Nevertheless, their orbital periods are very different. Long-period tail stars have orbital periods around our Sun of more than 200 years, while others, as already mentioned by you and me, require many millions of years for their return, whereby several 100 million years are not uncommon. Opposing these are the short-period comets, which come into the vicinity of the Sun and the Earth very frequently. Various of these short-period comets were influenced by the masses of the solar planets as well as by the mass of the Sun in such a way that they no longer reach any further than into the proximity of the orbit of the planet Jupiter, where they then make a reversal and begin their inner system journey anew. In contrast to the planets themselves, which move in the so-called main plane of the solar system, they are all kinds of orbital inclinations with comets. And it must also be said that the tail stars, in comparison to planets and moons, are very small and low-mass celestial objects, and that their diameters only range from a few hundred meters to about 70 kilometers. This is under normal conditions, when it doesn't concern a so-called giant or supergiant, which can be the size of the Earth or even larger. The actual core consists of rock, dust, and frozen water, as well as ammonia and methane, etc. Cometary structures are only visible as a result of their tails, for if this wasn't the case, then one could not see them in dark space. If an object comes into the vicinity of the Sun approximately, depending on its size, within 4 to 12 astronomical units, then the gases of the comet evaporate and form its tail, which can be thousands, hundreds of thousands, or even hundreds of millions of kilometers long, depending on the size and composition of the comet. Also, the diameter of the tail can be up to 100,000 kilometers and more. a mixture of gas and dust, etc. allows the comet to appear as a vague, small spot reflecting in the sunlight. However, the gaseous components in the spectrum of the comet's coma also have their own luminosity. If the comet comes closer and closer to the sun, then the radiation pressure and the solar wind naturally becomes stronger and blow the dust and gas away from the comet, whereby the coma or the tail of the comet forms, and indeed, opposite to the sun, for the particle flow encounters the comet away from the central star. In this way, it is also possible that despite the very low, intrinsic density of the comet and through its own luminous, gaseous components and through the reflection of the sunlight, this begins to shine and becomes visible to the human eye. What is still to be mentioned is that the tail components are stimulated to illumination by the high-energy components of the solar radiation. That is what I learned from Ptaah on my great journey. Quetzel says, and you still say that you would have memory difficulties since your collapse. Your statements are very accurate. Your memory is phenomenal. But now, dear friend, I would still like to talk with you about the private matters. My time is running out. Billy says, then get going, my son. For my part, I also have no more questions for today. The end.